So, moving on, let's go ahead with designing relational databases. Now, we are going to have an in depth discussion about the six phases of database design, which are collectively known as view modeling. So, view modeling begins by identifying the primary entities of the business function in question. So, let's just recall that entities are things about which the organization wishes to capture data. Entities are represented as nouns in a system description. So, a number of candidate entities can be identified as purchasing agent, receiving clerk, inventory, supplier, inventory status report, purchase order, and receiving report. But not all of these candidates are true entities that need to be modeled in the database. So, in order to pass as valid entities, two conditions need to be met. The first condition is that an entity must consist of two or more occurrences, and the other one is that an entity must contribute at least one attribute that is not provided through other entities. So, let's have an example. Let's say that assuming that the organization has one purchasing agent, then purchasing agent candidate fails condition 1. If, however, more than one agent exists, condition 1 is met, but condition 2 may be a problem. So if we assume that an employee table already exists as part of human resources or payroll system, then basic data about the agent as an employee are captured in that table. So we need to determine what data about the agent that is unique to his or her role of order placing need to be captured. Take note that we are not referring to the data about the order, but data about the agent. So, because we have no information on this point in our brief description of the system, we will then assume no agent specific data are captured. Therefore, the purchasing agent candidate is not an entity to be modeled. Another example is inventory. So, the inventory entity meets both conditions. The description suggests that the organization holds many items of inventory. Thus, this entity would contain multiple occurrences. Also, we can logically assume that the attributes that define the inventory entity are not provided through other tables. So, the inventory entity is therefore a true entity that will need to be modeled. The next phase is constructing a data model showing entity associations. So, the next step in view modeling is to determine the associations between entities and document them with an ER diagram. So, let's again recall that associations represents business rules. Sometimes the rules are obvious and are the same for all organizations. Sometimes the association between entities is not apparent because different rules may apply in different organizations. To reiterate an important point, the organization's business rules directly impact the structure of the database tables. If the database is to function properly, its designers need to understand the organization's business rules as well as the specific needs of the individual users. And the third phase is to add primary keys and attributes to the model. So add primary keys. The next step in process is to assign primary keys to the entities in the model. So the analyst should select a primary key that logically defines the non-key attributes and uniquely identifies its occurrences in the entity. Sometimes this can be accomplished using a simple sequential code such as invoice number, what else? Check number or purchase order number. Sequential codes, however, are not always efficient and effective keys. Through careful design of block codes, group codes, alphabetic codes, and mnemonic codes, primary keys can also impart useful information about the nature of the entity. Next slide there. Oh, before I forgot, I forgot to the attribute. So every attribute is an entity that should appear directly or indirectly in one or more user views. So attributes therefore originally derived and modeled from user views. So in another words, if stored data are not used in a document, report, or calculation that is reported in some way, then it serves no purpose and should not be part of the database. So that still includes in phase 3 the add primary keys and attributes to the model. I forgot to mention the adding of attributes. So here, next slide, the next phase is to normalize data model and add foreign keys. So here, uh, the repeating group data were removed to a new PO item detail entity. The new entity was assigned a primary key that is a composite of part number and PO number. So the attributes part number, quantity received, and condition code are repeating groups in the receiving report entity were removed to a new entity called rec report item detail. So a composite key composed of part number and repped number was assigned the purchase order and receiving report entities contained attributes that are redundant with the data in the inventory and supplier entities. These redundancies occur because of transitive dependencies in the purchase order and receiving report entities and are dropped. So the fifth phase of designing relational databases is constructing the physical database. So in this next step is to create the physical tables and populate them with data. This is an involved step that must be carefully planned and executed and may take many months in a large installation. So programs will need to be written to transfer organization data currently stored in flat files or legacy databases to the new relational tables. So data currently stored on paper documents maybe need to be entered into the database tables manually. Once this is done, the physical user views can be produced. And the final phase is to prepare the user views So the query function of relational DBMS allows the system designer to easily create user views from tables. The designer simply tells the DBMS which tables to use, their primary and foreign keys, and the attributes to select from each table. So older DBMS required the designer to specify view parameters directly in SQL. And newer systems do this visually. The designer simply points and clicks at the tables and the attributes.